So hello again everyone. So for today I'll be discussing thermodynamics. So again, I would like to say that the discussion that I will be making is like a review style or a review session. So I won't go into much details, and I'll be discussing with the assumption of you already know how do algebra and most of the basic maths. Okay, so I hope you guys like this video, since these videos will be a playlist. So this will have a series of videos, a lot of videos, and a lot of solving problems and examples. Okay, so I hope you guys like this one, and let's get into it. Okay, let's start. So discussing some of the principles for thermodynamics. So thermodynamics generally studies the heat power. This came from two Greek words, which are thermo and dynamics. Thermo stands for heat and dynamics stands for power, of course. So temperature, this is the measure of hotness or coldness of a body. Of course, you already know this one. So if we have here the SI unit and the EU unit. For the SI unit, the absolute temperature is in Kelvin. So the conversion for Kelvin to Celsius, you just have to add 273. While for the EU unit, the absolute temperature should be in Rankine. And for you to be able to convert Fahrenheit to Rankine, you just have to add 460. Now, conversion of Rankine to Kelvin, this one. The conversion for that, or the conversion factor, is you just have to multiply the given Kelvin, the reading in Kelvin, into 1.8. Now, take note of this one. This is very important. The change in temperature. The change in temperature or change in delta. The change in temperature in Celsius is just equal to the change in temperature in Kelvin. Okay, so take note for these two. You don't have to do any conversion for this one because they are just numerically equal. Okay, and the change in temperature in Fahrenheit is just equal to the change in temperature in Rankine. So those two again are equal. Fahrenheit and Rankine and Celsius to Kelvin. Now, ideal gas law. So we have here the general gas law or equation of state. We have the mass basis, which is usually used in mechanical engineering. We have PV is equal to MRT, where R stands for the specific gas constant or the molar gas constant. Okay, but for the mole basis, which is usually used in chemical engineering, we have PV is equal to NR asterisk T. So the R in PVMRT and the R in PVNRT are different. Okay, that depends. Now for the pressure, this should be in the pressure is absolute. So absolute pressure, that is the combination of or the sum of pressure atmospheric and pressure or and gauge pressure. So atmospheric pressure and gauge pressure. Now, what is the difference or what is the difference between the two? So the difference is the gauge pressure. This is the pressure that this is the pressure on the reading of the using a barometer of an instrument called the barometer. Okay, so the barometer is the instrument that you use to read a pressure. Okay, and then for the atmospheric pressure, we already have some common values here, and you can also use this as your conversion factor. So 1 atmosphere is equal to 101.325 kilopascal and is also equal to 760 millimeter mercury, equal to 760 torr, or equal to 14.7 psi, or pound per square inch. Now, for the temperature, of course, the absolute is Kelvin usually, or in Rankine, depends. Now, where R asterisk is the molar gas constant or universal gas constant. If you are using a Casio 991 ES plus, you can also locate that, which is the constant number 27. Now, the R is 8.31. That is the one that will be showing in your calc if you use your Casio 991 ES plus. 8.31, the unit is joule per mole Kelvin. Or the R is also 0.0821 when the unit is atmosphere liter per mole Kelvin. Okay, now the N here is the number of moles, represents the number of moles. So N here is equal to the mass all over molecular weight. Next, number two. So we have number two, which is the Boyle's law. For the Boyle's law, this is the isothermal condition or hyperbolic. So it happens. What happens here is the temperature here is constant, of course. Okay, so T is equal to C. Temperature is constant. Therefore, the temperature remains the same, or and you can also have that. You can also say that there is no change in temperature. Therefore, delta T, or change in temperature, is equal to 0 since the temperature is constant. So we can say here that volume is directly proportional, volume is inversely proportional to the pressure. So it will become PV is equal to C, which therefore P, pressure, and the product of pressure and volume will be constant. And you'll have your P1, V1 equal to P2 and V2. So stay in the video. I'll be teaching you how to do this on the problems later on. So you don't have to memorize all of those formulas. All you have to do is memorize as long as you know the conditions, so, and which parameters are constant. That's it. So you don't have to memorize all of those formulas. I'll be showing that later on. So for number 3, we have Charles' law. So isobaric condition where the pressure is constant. Okay. So for number 4, Gay-Lussac's law, or is also called the second Charles law. So you can have your isometric condition, isovolumic condition, or isochoric condition. Okay, so volume here is constant. So you'll have here something like this. So pressure is directly proportional to T. So you'll have here something like P1 over T1 is equal to P2 over T2. Again, I'll be showing you later on how to do that. So you don't have to memorize all of those. So general gas law equation, PV is equal to nRT. That is the general formula for general gas law equation. So nR is equal to constant here. Okay, so if it's constant, you'll have your P1, V1 all over T1 is equal to P2, V2 over T2. The general gas law equation, also called sometimes Avogadro's law. Okay, so for the density, in this case, this is a volume density. That the symbol that we'll be using for that, or I will be using for that, is rho. So volume density, or rho, is equal to m over v, or mass over volume, of course. Now, from the original equation, we have PV is equal to mRT, right? Now, if I will cross multiply the v from the left side to the right side, you'll have P is equal to m over v RT. Now, m over v is rho, right? So you can have here that pressure is equal to rho times RT, or rho is equal to P over RT. Okay, and we also have the specific volume, which is just very easy. Specific volume is just the reciprocal of the rho, or the volume density. Okay, so with that, let's move on to some examples.